This video is going to show you how to assess the impact of an advertising campaign on sales of bread while taking the standard error into account. So we're going to be using z-scores, and also I'll show you a situation where a t-score would be the most appropriate. Yet again, we're looking at the Great Harvest Bread Company data, where this first column here represents the days of the week that data was collected on. You can see data was collected for a 3-week period on Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday 3 times. The different columns here represent the different types of bread that we collected data for, and the numbers represent how many loaves of each type of bread was sold on a particular day. So for instance, on the second Sunday of data collection, we sold 375 loaves of Harvest White. So let's say that 3 weeks ago, Great Harvest Bread Company started a new ad campaign in the Henderson and Las Vegas area, and they wanted to see if there was a meaningful increase in sales after the ad campaign launched. And here's your population figures right here. Let's say that the original mean daily sales per type of bread was 320, and the original standard deviation was 192. So just for kicks, if we took this mean minus the standard deviation and then took this mean plus the standard deviation, that means in the population, most types of bread are selling between 128 and 512 loaves a day. That's a huge difference. I'm just going to delete these. Okay, so now before we can calculate the z-score, where we are going to look at the in-store bread sales per type for these 3 weeks compared to the mean before the ad campaign, and we're going to do a z-score for that. Before we can do that, we have a lot of things we have to do first. So first we need to know the sample size, the mean, the standard deviation, and then we're going to use that sample size and standard deviation to compute the standard error, or how much of a difference you would expect to see in mean daily sales per bread type just due to chance. And then we're going to use all that to do a z-score that compares the actual difference in the means to the difference expected just due to random chance. So let's start off by computing the sample size here. So just to kind of keep things organized, I'm going to go ahead and type sample size equals. Ooh, that's not how you spell sample size. Get over here. That's better. So there is a function called count A that allows you to count how many cells in a given range of cells have data that is not missing. And this is important because we can't simply take the, 7 times 3, 7, 4, 21 days, right? We can't take these 21 days times 1, 2, 3, 4, 5, 6, 7 types of bread to get our sample size because we don't sell Cinnaburst on every day. So the count A function is going to get us there. How many scores we're actually working with? What's our sample size? So we're going to do equals count A, double click, and then just highlight the full range of values. You can click and drag all the way down, or you can highlight the top far left, hold down the shift key, highlight the bottom far right, and magically it highlights everything in between, and then just hit enter. So our sample size is 141. We have 141 data points. All right, next we are going to figure out our mean for the sample of in-store bread sales. So we're going to say sample mean equals. Here we're just going to use the average function. So equals AV average, double click it, and we're going to highlight all the values yet again. Again, you can click and drag, or you can do the click the top left, hold down shift, click the bottom right. We got the happy dancing line, hit enter, and on average, per type of bread, we sold 368 loaves per day, or really 369 if we round. All right, now let's figure out the overall standard deviation for the sample of in-store bread sales per type this 3 weeks after the ad campaign. So sample, I'm just going to abbreviate SD for standard deviation, equals STD dot S, right? STDiv.S, because we're looking at a sample. S stands for sample, right? In a sample. Double click it, highlight all of our data again, I'm going to use the shift way this time. Hold down shift and click. It's all in there. Hit enter. All right, now we can finally figure out the standard error. So the sample, well, not really sample, just the standard error in general. Now, there's not necessarily a formula for this. You have to use the formula that I taught you, which is, let's see if it'll let me do it. Yeah. So remember, the standard error is equal to the standard deviation of the population divided by the square root of the sample size. So keep that formula in mind when I show you how to do this in Excel. Okay, so equals. Hey, Excel, we're doing a formula. Click the standard deviation from the population, slash for division, squirt, SQ, squirt for square root, double click that, and click on the sample size, and then hit enter. Yeah, I didn't put the little parenthesis at the end, so what? Correct it for me. All right, so our standard error is 16.169. So just due to random chance, even if the ad campaign had no effect on sales, you would expect to see about a 16 loaf difference between our sample mean and our population mean. So now we can standardize our sample mean based on the standard error to see if this is a meaningful impact. And remember, an extreme impact would be something that is a z-score of either 2 or above or -2 or below. In this case, we're shooting for 2 or above because we want it to be an increase in sales. So equals STA, standardize, double click it. Now, when you're using actual X values or scores instead of the sample mean, you would have an X here, a mean, and a standard deviation. But you can use this formula with the sampling distribution of sample means and the standard error by replacing X with your sample mean. Then you still use the population mean for the mean in the formula, comma, and then instead of clicking the standard deviation, you click the standard error and then hit enter. Now real quick, just for kicks, and I'm going to kind of scoot this over, click it and drag it over and put Z equals. So just for kicks, I want to show you how that works if you actually used the formula and manually did this without the standardized function. So remember, the formula for Z equals the sample mean minus the population mean divided by the standard error. So I can do this in Excel using manual formulas, and I'm going to get the same thing I did using the standardized function. So let's go ahead and just do it again, just to demonstrate that it works. So equals, parenthesis, because we're going to make it force order of operations on it. We want to take the difference between the means before we divide the standard error. So parenthesis, click on the sample mean minus the population mean, close it in a parenthesis, divided by the standard error. Bam! Same exact number. Magic. Well, not really. But check it out. If we look at this, we can see that we have a z-score of 3. So our actual difference in sales is 3 standard errors above the difference we'd expect to see due to chance. Or in other words, the actual difference in sales between the before and after, like the population versus the sample that of sales after the ad campaign, that actual difference in sales is 3 times larger than the difference we would expect to see just due to chance, even if the ad campaign did not work. So at this point, I'm feeling pretty confident that it's the ad campaign that probably resulted in this increase and not just, random sampling error differences that occur naturally just due to random chance. So this is good news for the marketing team. All right, now let's move into a situation where let's use t-tests to compare the mean bread sales for each different type of loaf specifically to a specified goal. So let's say that the original goal for the ad campaign was to achieve these levels or these number of loaves of sales for each bread type. So now we can use t-scores to see if any of the bread types appear to meet this goal beyond the margin of error. Now we're using t. We're not comparing our sample to a population. So we don't have a population standard deviation. We're comparing our sample to a specific population goal. This is what we're hoping will happen forever in the population after the ad campaign. And so we're going to use the sample standard deviation to compute our standard error or our estimated standard error. All right, here we go. So first, we need to compute the sample mean for each type of bread, how many loaves were sold. So sample mean equals, and you've done this before, equals AV, double click average. Now you can highlight all these values, or you can click the first one or the last one, and then go to the one on the opposite end, hold down Shift and click it, hit enter. Now remember, Excel's smart. It can apply this formula across the board for each different column here. And you know what, real quick, let's go ahead and freeze this top row so we can see it no matter what. So go to View, Freeze Panes, Freeze Top Row. Now when we scroll down, we can still see what type of bread we're working with. So again, good old Excel is going to copy this formula across and apply it to the data in each respective column. So we can see here, we're looking at the average for the C column, C2 to C22. And it just applies that across. Now, if that little go to the bottom right, find the plus sign, and drag over did not work for you, you can click here, drag over, go home, fill right. Okay, now we're going to compute the sample standard deviation. Make sure you're labeling your sheet to keep things organized for each different type of bread. You've also done this before, but we're doing it again. STD. This is a sample. Double click it. Highlight all of your values here and hit enter. Now we can copy that formula across by using the bottom right corner plus sign drag over or the highlight across fill right method. We've got our sample mean and our standard deviation. Now let's figure out how many days were included in our data collection for each type of bread. Now it's not going to be the same across the board because remember, we don't sell Cinnabursts on every day of the week. So we're going to use the count A function again, equals count, look for count A, the number of cells in a range that are not empty, double click it, and just highlight the values for that specific type of bread. Yet again, we can copy that formula over and it'll apply to each subsequent column. And we see that for all the types of bread we sell every day, of course, there's 21 in our sample. 3 weeks of data collection, 3 times 7 is 21. But for the Cinnaburst, we had 6 days, 21 minus 6 is 15, where we didn't sell Cinnaburst. All right, cool. Now we can figure out our standard error. How exciting. So SE, standard error, equals, remember that formula, the standard deviation divided by the square root of the sample size. This time it's the sample standard deviation, not the population, because we're doing a t-test. So equals sample standard deviation divided by square root, double click, of the sample size. Hit enter. I forgot my bracket, my parenthesis again, but Excel knows what I'm up to, so I hit yes. Yet again, I can copy this formula across. I'll show you the different way this time just for kicks. Highlight all the way, fill right. So now, just due to random chance, right, even if the ad campaign had no effect, I would expect to see about a 31 loaf difference in sales from my mean goal. All right, here we go. Now we can finally compute T. T equals. We're going to use the standardized formula again. So equals ST. Look for standardize. Double click it. Our X now is our sample mean, comma. Our mean is our goal. That's what we're replacing with mu in our formula. And our standard deviation is our standard error. I'm going to close it in a parenthesis this time to make Excel happy. Hit enter, and there is our T statistic. Copy it, drag it across. So just for kicks, to demonstrate that the standardized function works just like the formula for T, I'll show you how to do this by manually taking using the T formula, your sample mean minus your population mean divided by your standard error, or in this case, your estimated standard error based on the sample standard deviation. So just to demonstrate that, equals, parenthesis, click that sample mean, minus, click that mean goal, which is our kind of stand-in for the population mean, close it in a parenthesis, divided by our standard error right here that we computed, enter. Ooh, magic, same number. And Excel's smart. We can copy that formula across, and you see it yet again, same values. So the standardized function or manual formula calculations works the same. So remember, we wanted to see if any of the bread sales types appear to meet the goal beyond the margin of error. So what that really means is we need to have a value that is equal to or exceeds 1. We're not looking for extremes here. We just want to make sure that it's beyond one standard error from the mean. And remember, a z-score of 1 tells you that you have a sample mean that is exactly one standard error above the population mean. Or, it's one value that you would expect to see due to chance above the mean, if that makes sense. So basically, we're just looking for t's above 1. Ooh, this makes me sad, right? This harvest white, it did increase beyond, or it did go beyond the goal, right? 610 is greater than 600, but it's pretty close to that margin of error of 31. So we're not that excited about it. This probably didn't exceed the goal. It's just kind of close to what we'd expect to see due to chance. Then we look here, we see, oh, this is greater than 1. That's awesome. Let's make it bold. This one's greater than 1, so you can see that the actual difference between the sample mean and the goal is 1.6976 times larger than the difference you'd expect to see due to chance. So we're confident it's probably not just due to chance. This one's good, but not as impressive, right? It's still above 1, but not as much as honey whole wheat, but light wheat's still looking good. Ooh, pumpkin spice is looking great. It exceeded the goal, right? This 388 exceeds that 350 by 2.19598 standard errors. So it's even better than we would expect. Feeling sad about pumpkin chocolate. It didn't meet the goal. That's why it has a negative z-score. Our sample means less than our goal. Whoa. Sourdough is killing it. That ad campaign really set that sales number above the goal in terms of standard errors, the differences you'd expect to see due to chance. So the actual difference in sales between the actual sales of sourdough and the goal is 4.468 times larger than the difference you'd expect to see due to chance. This one's also better than what we'd expect to see due to chance, but it's not crazy impressive. So based on this, it looks like the ad campaign had the most substantial impact on the sales for pumpkin spice and the sales for sourdough. So I hope you enjoyed learning how to use Excel to kind of make inferences about the population based on samples and standard errors and population parameters or goals. And really the goal of this is not just to look at how the sample compares to the goal or how the sample compares to the original population, but if you get really high z-scores or t-scores, you'd be confident that from now on, you're going to see that pattern of results in the population because it's not just due to chance, it's due to the ad campaign.